Good morning, everybody, and welcome to ARC's fourth web window on real-time process analyzers. My name is Anne. I'm the moderator for today's session. Just shortly before we are going to start, we would kindly like to invite you to ask your questions in our Q&A session at the end of this webinar. We really would like to hear from you and would like to include your voice in this conversation. To do so, please use the question and answer panel on the right side of your screen. The questions will be sent to my attention and I will direct them to our today's expert. So without any further ado, I would like to pass over the word to our today's expert, Constanze Schmitz. Constanze, can you hear us fine?
Good morning. Happy to be here and tell you something about what ARC has been doing in real-time processor analyzer. We've been conducting a few studies and we would like to share some of our knowledge with you. Why are we doing process analytics? We would like to know what's happening in our process, which is of course a question that everybody who's in processing is asking themselves. Our goals are to produce a high quality product, achieve a maximum consistency while doing an optimized usage of our time, our personnel, and our raw materials. Sadly enough, this is not as easy as it sounds. We have challenges. We have to know the chemical composition or the physical properties of the product that runs in our pipes. We have to keep things inside our margins, and we want to have a consistent product. We have regulations that ask us to trace all that we produce, so we can go back in our historian to see what we have done. These days, in a lot of the industries like food and beverage especially, we have a lot of changeovers. So batch processes demand a lot of the analytics. What have we done till now? Well, a few years ago, what we did was on a regular basis, we sampled. We took a little sample to a lab where it's got analyzed. And a few hours later already, we knew what happened in our process. This has a lab analytics has certain advantages, of course. We have the ability to execute precise, complex analysis. Normally, you have an LIMS system, a laboratory management system, that allows for full traceability. There is not much risk of contamination because we're working in a sterile environment, and we're able to test for even the most complex parameters. On the downside, of course, the whole process is time-consuming. So the data that we get is really not real time. It is expensive, and it requires a highly skilled workforce to execute all these samples, all these analysis. So these days, most of us hope that we can use online process analyzers. I'm going to define this because we use online and inline. Some of them are inline, which means they're directly in the process. We're going to see that later on. It's especially optical analyzers that are connected to the process through a little optical window. And we got online, which is working with a bypass, which means a sample is taken directly out of the process and is prepared and analyzed very close to the process. The advantages, of course, are that we get real-time or very close to real-time results. While we still need skilled personnel, it is not the level that we would need in a lab. We will not lose any of our product, which might be interesting, especially in industries like the pharmacy, where the raw products are very, very expensive. And we achieve full traceability because the information can be fed right into a control system. Sadly, not all parameters are available yet. And the high maintenance that I mentioned is something to keep an eye on. ARC has conducted 3 different studies on the different sort of analyzers. The first 2 I would like to introduce are the electrochemical and the optical analyzers. Electrochemical analyzers can be used for a wide variety of parameters. Best known is normally pH, ORP. These are the ones that are used in huge amounts. They measure the concentration of elements by oxidizing the gas or fluid to be measured and analyze the resulting current. Thus, can give us the result of what is in our process. It does use consumables which have to be put into a calculation. Optical analyzers measure characteristics in elements through light waves, UV, infrared, visible light. They use technologies like fluorescence, reflection, absorption to analyze what sort of elements we might have in our process, and it doesn't need any consumables. The third one that we have analyzed to make the round full is gas chromatography. Gas chromatography separates and analyzes compounds that can be vaporized without decomposition. I'm happy to explain more about that technology if someone is interested in the Q&A. This technology is mostly used in oil and gas, where they even have 2 or 3 because they need to have redundancy. Gas chromatography has the advantage that it quantifies the results of our analysis, so we can determine relative amounts of the elements that we're looking for. It is not cheap to install. It's just not the gas chromatograph itself. Depending on the situation, you will need a shelter, a lot of cables, cooling, sample equipment, and all these things have to be taken into account. And this is all technology. If you're interested, we do provide additional information also on the software and the service part. So depending if you are a user or a supplier, as a supplier, it might be interesting for you to see what sort of business is available in these 2 areas. And as a user, it might be interesting what sort of services most suppliers can offer these days to make life easier on your side of the business. This one I borrowed from someone at a big German chemical plant, and it's just a small overview to see what is actually analyzed. And then we see what I mentioned before, pH ORP is a major part. It's more than a quarter of all analysis in the chemical industry is this one. And then you have, because we talked about optical methods, which would be the purple little pie slice. This part is not as big yet, but it is a growing part, and it's very interesting to see how the people will apply this and find new applications for it. Also, I'm happy to go deeper into that if somebody is interested. More interesting is probably in which industries are we applying real-time analysis. It is a bit different depending on which analyzers you use. The optical and the electrochemical ones is a bit in balance. But the interesting thing is to see that, especially in those electrochemical and optical analyzers, they are used in a lot of non-cyclical industries. These are industries that don't react to markets in a way like the oil and gas or consumer industries normally do, because they are essential, like water and wastewater, food and beverage, pharmaceutical and biotech. These are also the industries that have a lot of standard and regulations they need to follow. Especially the pharmaceutical industry is a first-time adopter. They are normally the ones that lead the way in analysis because of the value of their raw materials and because of the regulations that are very, very severe that they have to follow. Food and beverage is not far behind. Water and wastewater is so big because it's so essential and it is used in every country in the world, and lots of countries need to or renovate their old installations or even install them first time. It looks a bit different for GC, for the gas chromatographs, which are, as you can see, for 3/4 in oil and gas related industries. These, of course, are much more sensitive to the oil price that we have at the moment. Thus, I put GC in here because we have to be complete, but the market development that we expect for the first 2 compared to GC is quite different. We're going back to the parameters that can be measured. We leave pH ORP, which is quite well known. We have the electrical characteristics of conductivity and resistivity. What a word. More interesting is the green part, this is the one that is growing. The suppliers are offering more and more measuring devices for certain compounds and elements, which is of course something that we are looking for. We don't want to just know what is the pH value of my process, but depending on the process, we need to know exactly what is in our products. Dissolved oxygen is a favorite and will always be strong and keep up. Depending if you're a user or a supplier, I think it is very important that you follow certain strategies. You have to stay on top of regulations, and not just your national ones. Depending on the size of your company and if you export or not, you have to keep an eye on regulations all over the world. This means that the more you know about your process, the easier it is for you to fulfill all the requirements. As we all know, we have a problem with skilled labor. If we see how many people are doing university degrees in engineering, in most countries it is a problem. We don't have enough people. We can calculate it already that we will run out of engineers, doctors of physics, all these people that we might need for analytics. You have to be sure that the people that you have, that you use them to their best abilities, that you keep training them, that you keep offering them new opportunities, and that if you do a change, like putting your analysis from the lab into the process, that you take them with you mentally. They need to understand why things are happening. They need to understand that this is important and that they are part of it. You have to go beyond technology and supplier evaluation. It's not just a product. It's not Amazon. You don't order a book and the book comes in and you're happy with it. You don't want a little box with a gas chromatograph in it. What you need is someone that knows your process, that understands your application, and that is able to do a custom tailored solution for you. Perhaps even commission it, install it, in some cases maintain it afterwards if you do not have the manpower or the expertise in-house. All these things are possible these days. You just have to look out for the right supplier. Also, because if you want to have a physical presence of your supplier, be sure that you have one that is close to you. I mean, it should be obvious, but the prices seem sometimes to be more interesting. Cultivate internal and external peer relationships. A lot of companies tell me, oh, it is so expensive to send someone in certain associations or this and that. But it has its value. If you want to stay up to date and if you want to be part of the decision process of what is going to happen in the next years or decade in your industry and in your technology, you need to keep abreast. You need to be part of it. The next point, rely on supplier expertise. In the end goes what I just said. Make sure that you have a good fit, someone that understands you, that you have a good communication with, and that goes beyond sending you an analyzer in a nicely wrapped package. And choose the correct technology. There are some amazing technologies out there, and in some applications you might actually need them. But lots of them, while they seem simple, they might already do a lot of difference in your process if you have one or two parameters that you can safely measure and directly use the data afterwards. We have, of course, strategies for suppliers too. The importance is they need to raise the awareness of the benefits. People need to understand why you should do a process analytics in that way, even though it is not a cheap way and it needs a lot of organization. So as a supplier, you need to deliver application knowledge. You cannot just go in there and have a vague idea of what is going on. You need to have expertise. Certifications. The moment you export, it's so important. Keep an eye on the certifications. Be sure that you fulfill them. I know the process is expensive, but be sure that you have the right certifications and that you have flexible product that can be adapted in a lot of different environments and a lot of different products. This is the other side. Get involved in organizations. It's the same for the suppliers as it is for the users. The other thing is, if you do not have the expertise in-house, We are quite far in the development of analytics. These days, most probably, you will not be able to organically develop the technologies in-house anymore. There are a lot of little expertise companies out there. So growth by acquisition, if you need more products in this area, is something to be considered. One of the most important points that we have been talking about in a lot of other areas too is lifecycle services as a product. I keep repeating myself, I do know that, but it is very important to see the product from the start to the end, from the one moment you develop it to the moment the user is ordering it, commissioning it, installing it, maintaining it. What is going to happen? You will need to provide spare parts. You need to keep an eye on developments. These analyzers are in computers. They need to be updated. You need to be open to certain standards and communication. All these things need to be considered. What do we want to achieve in the end is automatization. We want to be able to sit in front of a screen and have a bird's eye look into a process. Real-time process analyzers are directly connected to your DCS system. So you have the ability to see exactly what is going on, take short decisions, have the possibility to work much closer to your margins, to see mistakes very fast so the loss of product is reduced. In batch processes, you may be able to restart your batch much faster if you're absolutely sure that your lines are clean. No, let it run for another 5 minutes just to be sure. All the data that we get, we can analyze right there, but we can also track, record, and validate it afterwards. We can produce models, which will allow us to predict conditions even earlier. You can see the composition of your materials, especially also you have varying degrees of raw materials coming in, and your finished product also always needs to be the same. I mean, good example is always beer. Everybody likes it, and everybody understands that the raw material is not the same every year. Conditions of your process, you can see much earlier if the temperature is moving, if something is going wrong in there, you can react faster, and every moment you can react faster is saving you money. The information gained, as I said, will be available in Fusion reports, can be used later on as historic data, as proof that your process was running correctly, as it can be used to analyze mistakes that have happened. All these things are very valuable. We covered the other 2 points. The other thing, of course, is predictive maintenance. These days, devices that are that highly sophisticated and well attached do know how they feel. They will tell you in time when things have to be changed, especially if you have a continuous process. It is very valuable to know that an analyzer needs to be exchanged in the next 14 days. If you have a downtime that you have planned anyway, or you have 2 weeks to find a slot where a downtime can be planned, perhaps a few other things that have to be done too in preventive maintenance to exchange a few seals or so can be done at the same time. This is an advantage that cannot be ignored. Oh, I'm wonderfully in time. We go to our conclusions. Online and inline process analyzers deliver close to real-time information on the process medium and the process itself. It allows for fast, well-informed reactions to deviations and can speed up batch changes. Sadly, it's not available for all parameters yet, but there are new methods that are moving from the lab to the process right now. And the high maintenance that I have mentioned, and that is not to be underestimated, but it is liberating laboratory time and workforce, which might all move over there, or you can train already skilled maintenance workers to actually execute these jobs. And a bit of advertisement in our own business. We wrote studies. We have 3 studies at the moment available that are looking into these 3 different sorts of analyzers. For the end of the year, there's a roll-up planned, which means we'll take data from all these 3, while dropping, of course, some of the technology information. We cover all the regions, all the industries that are in there, that are important, and we're always happy to answer questions about it. Thank you very much for your attention. Oops, no, not good. There we go. And I'm happy to hear some questions if you have any. Thank you.
Thank you, Constanze. This is all we have for today's webinar. So please visit our web pages at arcweb.com and our industrial IIoT blog page to stay tuned for new trends and research topics that we cover. And again, on behalf of ARC, thank you for joining us and taking your precious time to view our presentation.